Thanks for reminding me. Now, did that kill my camera? No, it did not. It must be a Friday. All right, cool. So welcome to the end of week 5. This is officially the halfway point of the quarter. So 5 weeks down, 5 weeks to go. So hopefully everyone finished up PA3 and got that submitted. And I've started grading those. It's going to be a little while before I get through them. I got a bunch of stuff going this weekend, so I will get them graded when I can. Hopefully by Monday, but if not, soon after. So PA3 is history, and we are on to PA4. So let me talk you through this assignment. Let me show you a sample execution of it, and then we'll talk about kind of the assignment details, and then we'll start digging into the coding aspects related to making this work. So programming assignment 4 is the game of dots. This is like the greatest game in all of history, except for all the other games. But it's a simple game, and let me show you kind of how this works on paper. So, I played this when I was a kid. I played it when I was an undergrad. Basically, you start off with a grid of dots, and depending on how much time you have to kill, you can make a bigger grid. But let's just start with a 5x5 grid of dots. So yeah, dots and boxes, I think it's also called. And so you take turns, right? It's 2 people playing, and you take turns drawing lines. So you can draw a horizontal or vertical line, and your goal is to complete as many boxes as you can. So I might draw a line here. The person I'm playing might go there. I might draw a line here. They might go there. I might draw a line here. If you can draw a line that completes a box, you win that box. So if it's the other person's turn, they would probably draw a line right here, and they would put their name. So I'll put O for other. They put their name in the box. They've got 1 box. And when you complete a box, you get to go again. So in this case, they could draw a line here. That would complete a second box, so they'd get that one. And then they get to go again. And so they would draw that line. And then I might go, and they might go, and then maybe I'll go here and complete this box and draw another line, and maybe they'll go there, and I'll come here and complete a box, and maybe they'll go over there, and I'll go here. And you just keep going. And basically, when all the lines have been drawn, whoever's got the most boxes wins. And it's possible to tie, but usually one person wins. And you take turns unless you complete a box. Anytime you complete a box, you get to go again. And, you can have situations like this, where if it's my turn, I could draw this line, and I would win 2 boxes. Right? Because I completed 2 boxes, and I get to go again. So I'll go like right here. And so you're going to design and implement a computer version of this. And on the computer version, it's still 2 people playing, and they're sharing, a pen and a piece of paper. So they're sharing the mouse. They're using the same screen. So they're playing on one computer. PA5, we're going to extend this to a networked version. So 2 people can be on different machines connected through a network connection. And they'll both be seeing the same playing field, and they can play the game together. All right, so let me show you an example of how this plays out. So here's one implementation of the game, and yours does not have to look like this. We'll talk about what's required and what's up to you. But this is my basic playing field. It's always an 8x8 array of boxes. It doesn't do any fancy resizing or anything. It's just all kind of statically sized. And this is for 2 people. So if I try to click before the game is going on, it'll tell me click the start button to begin. If I try to start, it'll tell me I have to enter names for people. So I'll be Nick, and I don't know, I'll play against my brother Phil, and I'll say start. Okay, so So I'm going first. So it says current players and there's our score. So I'll go there. Now it's Phil's move, so he'll go there. I'll go there. Maybe Phil goes there. I'll go here. Maybe Phil goes there. And I'll go here. All right, so it's Phil's move, right? So if he goes right here, then maybe I'll finish this box. I get an N in the middle. I've got a score of 1. I get to go again. So I'll go here because I'm not very good at this game. And he can go right here, and he's going to get 2 boxes for that. So he gets both of these boxes. Now he's ahead 2-1. And we just keep going like this. Now for an 8x8 board, it takes a long time to finish. Right? It's a few hundred lines you have to draw. But, you know, you start to develop a strategy for this, and you can set yourself up with really long runs of good luck. Right, so if it's my move right now, I can go here, I'll get 2 boxes. I can go here, I'll get that box. I get to go again, and I get that one, and that one, and that one, and that one. So that's a big run for me. All right, it picks up illegal moves. If I try to click a line that's already been clicked, it should tell me it's already taken. And don't forfeit your turn, because if you can forfeit a turn, you can cheat. So it's still my turn. It's still Phil's turn. So if he tries to do an illegal move or he clicks somewhere out here, right, it's not going to do anything until he makes a valid move, and then it switches to mine. There's a restart button if you just want to begin over again. One player gives up. That'll set everything back to 0. All right, so that's the look and feel of it. I have some debugs coming out here, but everything that I'm doing is playable just from looking at this playing field. Okay, so that's the basic setup. So let's talk about details. So that's the synopsis of what I just described for the game if you're not familiar with it. First detail, it's a group project, okay? Now you're allowed to work alone, or you can work with up to 2 other people. So groups of 3 or 2, or you can work alone. I strongly recommend, though, that if you break this up into a group, that each person basically develop the complete game themselves. And as you're working, you know, use the group aspect to bounce ideas off one another if you're stuck with something in the code, if you're trying to debug something, right? You're allowed to work with the people in your group. So this is a fairly ambitious project, right? This is definitely going to stretch you. And so I want you to be able to get help, you know, from the people in your group. And, you know, to some degree you can partition the work, but you've got 2 weeks to do this. It's totally doable in 2 weeks. So what I don't recommend is splitting up the work and saying, you know, I'm just going to work on the graphics. I'm going to make it look really beautiful. And, you know, this other person is going to work on the engine, and this other person is going to work on the GUI part, right? Don't do that, because this is a really good exercise in working with event-driven code and getting deeper into the idea of objects and the whole mindset of object-oriented programming. And this is the kind of thing you'll encounter when you do, you know, game development, and if you do Android development. When you get into larger scale systems, a lot of the stuff is set up like this. It's event-driven, and you have to work with these pre-existing systems and kind of squeeze your piece into some framework that's already there. So it's really good if each person sort of does this whole project. At the very least, you want to make sure that you understand the entire project from beginning to end, instead of, you know, just doing 1/3 of it. But it's up to you how you decide to break this into pieces and work in a group setting. All right, if you're doing this in a group, make sure that all of your Git repos are consistent at the deadline, because I'm going to download, and whatever repo I find first, I'm going to start grading that. So if the working code is in your repo, but somebody whose name comes earlier in the class role has a repo with an old version, that's probably going to be the one I end up grading. So either make sure all the repos are consistent, or, you know, get rid of the repositories that aren't the ones that you want graded. rename them to something else or move them out of the way. And most important of all, make sure that in the top of every .java file, right up at the top, the full name of everybody who's in your group. So that when I'm grading, you know, whatever file I happen to be looking at, I can look up the first line and see the names of everybody in the group, make sure that everybody gets credit. All right, so that's easy to do. Just make sure that you put that in every file. All right, there's some requirements, and then there's a lot of leeway in how this is set up. So requirements: the program should begin by drawing the grid of dots. Okay, and I'd like you to begin with a board with 9 by 9 dots, so 8 by 8 boxes, and I'd like each box to be 50 by 50. Okay, this will make it fit easily on, you know, what I'm going to be grading it on. I don't have to do a lot of resizing and so on. But you definitely should not hardwire these, right? Don't write code that says, you know, set length equal to 50 and set height equal to 50. Make these magic numbers, 8 by 8, 50 by 50, make them variables somewhere, right? Put them in one class, make them statics if you like, and use the values by referring to the names that you give to these variables. So that if you're developing this and you want to know if the end game works, you can easily change it to, you know, a 4 by 4 grid instead of a 9 by 9 grid. Or if you want to see what happens if you know, you fill up your whole window, you could make the boxes bigger by just changing a variable. So make those variables. You want to have 2 people playing. You want them to be able to type in their names in a text field, okay, and then hit a start button to begin playing. Once the game is going, the game should keep track of whose turn it is and should display that in some way so that, you know, looking at the board, you can tell whose turn it is. When you click inside the grid area, you should draw the line that the person clicked on. If a box has been completed, the game should notice that, add the initial of the player who made that move, put their initial inside the box, and then let that player take another turn. If you didn't complete a box, you switch turns after each click. And then keep track of the score for each player, display that somewhere in some fashion, and when the game is over, note that and indicate who won the game. And then have a restart button so you can start over. Okay, those are your requirements. But everything else is pretty much up to you. So the look and feel of this, you know, where do you want to display things? Do you want to use colors? Do you want to use fancy effects? You know, do you want to put a numeric score, or do you want, you know, a meter showing who's ahead, or do you want bars that fill up as you get boxes, right? Go wild, right? Explore the widgets that you have. Have fun with this. And you know, you need to get the game behavior to work correctly, but once you start getting that under control and you know, you can see a pathway to the end, then you can start branching out with kind of the artistic elements of it if you like, right? So I'll come back to setup and suggestions in a few minutes. So submission, make a subdirectory named dots, and make your main class called dots.java. And make sure whenever you make a class in Java, if your class is called X, make sure your file is called x.java, and you got to match the case. Okay, if you call it dots with a lowercase d, it's not going to compile the same way. So call your main class dots, put your repository under your CSE223 dir, just call your subdirectory dots. And same business as usual, I'll run it by just, you know, compiling dots and saying Java dots. I recommend working in Eclipse just because it will simplify your life as far as dealing with swing, as far as doing all the imports you'll have to do, and so on and so forth, but it's up to you. But I will not run it in Eclipse. I'll be running it from the command line. So whatever you do, make sure that when you think you're done, you can go to the command line. You can just say Java space dots uppercase D, and assuming you've compiled everything, it'll go ahead and play your game. and do that, from a command line in a different directory to make sure you don't have some, special package that you downloaded or something like that I might not have access to. Grading is straightforward, right? So you can use this more as a checklist rather than like, where do I want to get points? Obviously make sure I can download and compile your code. Make sure it draws the fields of dots, shows an initial score of 0 each, has a way to enter names, pays attention to those names and uses their initials in the boxes, responds to mouse clicks, draws lines between dots based on where you click, does not let you click, on a line that's already there, because that lets you cheat, adds initials to completed boxes, keeps track of whose turn it is correctly, reports the score, and has a restart button. So you do all those things, you got 100 points. Did you really? That's pretty cool. All right, let me talk about a few suggestions on PA4. You're not required to do these things. Yeah, totally. Eclipse is not as bad as some, as far as being able to get to that stuff. So suggestions, if you've got your own way to do this, if you've got your own ideas about how to organize this and so on, go for it, right? But for what it's worth, here are some things to think about that may make this smoother for you to do. So first thing is, this is event-driven code. Okay, we're going to have our main program, and what do we want to have happen? We really want to know the person has clicked the mouse right here. That's pretty close to this line, so I'm going to draw this line. And now I'm going to wait for another mouse click, and that's going to be the other person's move. And so, in C or in the Java code we've done so far, this would be, like PA3, right? Open up a file, read it in, close the file, ask the user a question, wait for them to say yes or no, move down to some node, ask another question, and so on, right? That's not what this is going to look like. Okay? Mostly, our code is not going to be doing anything. So this is event-driven or interrupt-based code. Mostly, our code is going to be hanging out in the background waiting for events. And what's going to happen is someone's going to come along and they're going to move the mouse somewhere and they're going to click the mouse button. And at that point, some piece of your code is going to be called. And that code has to do something and exit. It can't hang out, it can't go into an infinite loop, it can't wait for some other mouse click to occur. It's got to do something and exit, right? Just return. And if you don't do that, things will start to get really, really funky. So if I were to hang out in here, if I were to make a while loop which says, while there's still boxes left, wait for a mouse click, nothing's going to work. Okay? This is that interrupt lab from 270, if you've done that. When the mouse gets clicked, a piece of our code will start running. It's going to have to do something to register the fact that this line should be drawn, and then it's got to get out of there. It's got to return. So that's one difference. The second difference is we don't get to draw on our display from our code. Okay, we can't write code that says, if a mouse click occurs, draw a line right here. The drawing is going to be done in a fairly indirect way. And this is standard with Swing and Android and all kinds of other things. So here's kind of what we're looking at. Here's our code. Here's some events. Here's our widget, so this is our JFrame. And when, a mouse gets clicked, that triggers our code, and our code does some stuff. And it has to do its stuff and exit. And the code cannot paint on the JFrame. Alright, so there's some events. Here's our code, there's the JFrame. So a mouse click occurs, our code does something. We want to draw a line on here, but we can't do that, right? There is something in here in swing that can paint. So that's I'm just going to call that swing. And this can paint. This can actually do the drawing on the JFrame. So how do we make a line appear on here? Well, we have memory. And we basically read from and write to memory. And swing will read from memory. And so if we want a line to appear on here, what our code has to do when we get a mouse click is make some changes in memory so that when swing looks at the memory, it says, oh, I should draw a line right here. Or, you know, for that matter, I should draw a bunch of dots. Alright, so we'll go through an example of this today, and we'll play with this more next week. But it's going to be this very different feel from, you know, if mouse is clicked, then draw a line. Right, that's a procedural approach. This is going to be, you know, when a mouse is clicked, run this code, and this code should set a flag in memory. And meanwhile, we'll set something up in swing so that when this flag is true, it draws a line. All right, so you got to be ready for that kind of mental shift. Otherwise, you know, it's going to feel really frustrating and awkward. All right, so definitely ask questions, right? This is going to be different for most people. So you want to be working on this, you know, as soon as possible so that you can come up against the trouble points in the questions sooner rather than later, and we can talk about those. Let's see, when you draw diagrams and arrows, are you following an official format or is it ad lib or kind of both? Oh, this is totally like ad lib. And yeah, I don't have any particular skills at this. I used to work with a guy named Eric who, like, he'd go to the whiteboard and you could hear angels singing. I mean, he just drew the most beautiful pictures and they really carried a lot of information, but this is just totally ad hoc, off the top of my head. All right, suggestions, right? Make a class to represent a single box. So what is a box, right? Well, you know, it's an area between 4 dots. It might have some lines, it might have an initial, it might have some lines, all lines, no lines. That's a pretty simple object, right? It's basically, you know, you could have 4 booleans to represent whether each of the 4 lines has been drawn or not. You could have a flag to say, does somebody own this? You could have a character to say, what's the initial of the person who owns this, right? That's a pretty simple object, but if you make that its own object, right, make a class named box, then you can create your board as just a 2-dimensional array of boxes. So you can make a class named board, which stores the kind of memory view of the playing field, and the main object in that would be an 8x8 array of box objects. So you want to spend a lot of time thinking about how you're going to structure this, right? And in C we would just make, you know, a 2-dimensional array and you know, come up with some way to jam some booleans in there or some flags or something. But think about them object-like, right? Now suppose I have a board class and I've constructed, you know, a board from that class, so that's my playing field, and part of that board is an 8x8 array of boxes, and each box has a flag saying, you know, does somebody own this, and it has some field saying who owns this. Okay, think about this. Suppose I want to know what the score is. The kind of traditional approach to do this might be, you know, start off with each person's score equals 0. and when I complete a box, increment my score. When the other person completes a box, increment their score. And then when I want to know the score, just look at those two counters and, you know, display those or compare them or whatever. And that's fine, except that, you know, I have these two pieces of data that are sacred now. And, you know, if somebody hits the restart game button, I've got to remember, oh yeah, I need to reset those things back to 0. Or if you were going to make an undo feature, so you could take back a move, you would need to know, okay, did I just take back a move that, you know, undid a box, and whose box was that? And let's decrement the value of this sacred integer so that the score is still accurate. Okay, so that's kind of a procedural way to do it. What we'd probably do in Java or any other object, though, is we would make a method called, you know, player 1 score, player 2 score. It would be a piece of code. And in this case, all that code would have to do is go through your 8x8 array and count how many boxes are owned by player 1 or player 2. And the advantage of that is we don't have these sacred integers now that have to be constantly maintained and updated, and anything that affects the score has to know about those integers and adjust them accordingly, right? If player 1 score is a method, it doesn't matter how the boxes got changed. Did someone hit a reset button? Did you undo a move? Did you take extra moves, right? Anytime you want to know player 1 score, you call that method. It goes through the array. It adds up how many boxes have player 1's initial in them, and it gives you the score. So this is, you know, modularize, 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 right? Really kind of think about, you know, if you need something to be stored in a variable, store it in a variable. But if it's a piece of information that can be calculated from other things you've got in memory, it may be better to just write some code to do that calculation, right? We're not worried about speed here. So maybe it's wasteful to go through and, you know, look at 64 boxes and add them up. But we're not going to worry about that. We're not going to notice the time being used. So make yourself a lot of methods, right? Have a method for initializing the game board. You need to initialize the game in the very beginning, right? Draw the dots, don't draw any lines, set the scores to 0, switch the player to whoever the first player is to indicate it's their turn, and so on and so forth. When you hit the restart button, you need to do all those things also. If you put all that code in a method called restart game, your restart button is one line of Java, just called board.restartGame, and everything is done. Right? Make a method for updating the score. Make a method for checking if the game is over. Make a method for checking if a move is legal. Right? All of these things, think about, can I put this stuff in its own method? Right? So that you don't have, you know, some huge method called, you know, play game, which is 500 lines of Java, and you know, filled with interdependencies and so on and so forth. Try to keep your code small and tight. Okay, so it does, you know, like one thing and gets out of there. And this will also work well as far as the event-driven mindset that we're working with. All right, we'll play with mouse clicks on Monday. We'll talk about so we had some opportunity for this in PA3. In PA3 you can get away with kind of a looser coding style more easily. It's gonna hurt a lot more in PA4 if you go down a path like that. And inevitably, you know, we'll go down that path a few times, but you got to be willing to sort of come back and restructure things. And this is also part of where the group aspect can help, is if you're each developing this, work on this for a day, right, and then come back and compare notes. And you'll probably end up with a much better piece of code in that way. So mouse clicks, we need a way to you know, take the XY coordinates of a mouse and figure out, you know, did the person click something in between these two dots, and if so, then we want a line right here. But if they clicked, you know, in between these two dots, then we want a line over there. So Monday we'll go through some of the arithmetic for that. it's really simple to do, but you got to do it, you know, a certain way. And so I'll give you a handout probably that I made for sort of taking bare XY coordinates and translating it into, you know, what box are we in, what line are we pointing to, and so on and so forth. So I don't want to worry about that too much right now. But ultimately, your code is going to say, you know, here's where the person clicked, that corresponds to this line. Let's draw that line, and then you need to see if that completed a box. And keep in mind that one line can complete more than one box. But you're not going to draw a line in that point of your code. You're not going to draw initials in that point of your code. You're not going to necessarily update your score in that point of the code. What you're going to do is update memory. You're going to have, you know, maybe an array of boxes, and each box has a Boolean saying, is this line drawn or not? You're going to update those Booleans. All right, drawing the board. We'll play around with drawing next. Main thing, be methodical, right? Think about the structure. Start working with that structure. If you're finding the structure is working against you more and more, take a few steps back. See if you can restructure it. Have a conversation with your team members and see what they've run it into. Have they addressed this? Have they got a different idea? Iterate, right? This is not a sit down, work for 6 hours and you're done kind of thing. I mean, you can do that, but you want this to be ideally a program that when you're done, you feel good about it. Not like, I sure hope that doesn't break when he tests it, right? You want to feel pretty solid about this. And we're going to build on this for PA5. PA5 will be the networked version of PA4. So you don't want to, you know, end up with a Frankenstein monster that you hope, you know, behaves itself. So that means being able to go back and kind of rethink things. And it means working logically. It means using good names for methods and variables, right? Don't call your variables A, B, C, X, Y, Z, S1, S2, right? We've got, you know, freedom of using long variable names. Score of player 1 is a pretty unambiguous variable name, right? Whereas S1, you know, or A, not so clear what's going on. So you know, feel free to adjust your habits and try different things to see what's going to make this work best for you. All right, time is flying, man. So let's talk about painting. So we have our J-frames, and we know there's a JPanel in here that holds other widgets, right? And we're going to have some buttons and some text fields, and you know, some radio buttons or whatever. And we're going to have a playing area. Okay, I'm going to suggest this playing area should also be something like a JPanel. So let's draw a rectangle or a circle. So we're going to call this Dottie, which is probably what SpongeBob would call it. And we're going to say File, New, Other JFrame. And I'll just call it Main. Alright, so let's come into the design window and I'll put down an absolute layout manager because we don't need it to be resizable and so on. And you know, you're going to have a button and you're going to have maybe some labels and who knows what else. But somewhere in here is going to be a drawing area. So I'm going to take a JPanel and I'm going to drop it right here. And I'm going to make it bigger than that. I actually mean it. Okay, so there's a JPanel. And if I run this, it's not going to look very interesting. So let's just add a border on here just for now at least. So I'll pick the JPanel, I'll go to Advanced Properties, I'll go to Border, and I'll just add a bevel border. And so now if I run this, we can see, you know, where our playing area is. All right. So if we look at the documentation for a JPanel, there's a method called paint, which comes in from a component. And paint basically is used to draw things on the panel. So the panel is going to be like our palette, what we're going to draw lines and circles and dots and so on top of. And the paint method needs a graphics object. So graphics is another class, and this class comes with a bunch of useful methods like draw characters, draw image, draw line, draw polygon, draw oval, and so on. And you can set background color and foreground color and all kinds of stuff. So this is the main package we're going to be using. The main class for actually drawing things is graphics. And it's used by the paint method of the panel class. But, you know, if I just go ahead and I run this program, it's not going to draw anything for me because I haven't told it to draw anything. What I need to do is I need to change the paint method of the panel class to say, hey, paint a rectangle, right? Or paint a pattern of dots or something like that. Well, you know, this panel in here, panel is a JPanel. How am I going to change the paint method of JPanel? Because I didn't write the JPanel class. That's part of Swing. That's been written for me. I'm importing it, right? I import a JPanel right here. How am I going to change the paint method of that? Any ideas? Yeah, we're going to extend and override. Perfect. So let's make a new class. And this is something you're going to do again and again. You're going to do it in here. You're going to do it in other development environments, other classes, and so on. So I'm going to make my own version of a JPanel. So I'm going to call this my panel. And I'm going to put a paint method in here. So I'm going to do public void paint graphics G. And I'm going to do g.fill oval, and I don't know, I'll just put an oval at, you know, 50, 50, and I'll make it 100 by 100 circle. And you notice it imported graphics for me along the way. As soon as I started typing in this method, it figured out what I was talking about. All right. So this is called my panel. And what I'm going to do is I'm going to change this to use my panel. It's going to say my panel equals new my panel. Now as soon as I do that, I get a bunch of errors. For example, there's no set border method. Right? Why is there no set border method? Because I don't have one in here. So what's missing, I have to actually make this an extension of a JPanel. And now it's going to get all the stuff that's inside JPanel, including, you know, set border. Now I need to import, and if I just kind of hover over this, it'll say, would you like to import this from Java X Swing? I can click on that, and it does my import for me. So this is all set to go now, and if I go ahead and run this, right, there's my, my panel with a circle in the middle. So that's Hello World. Now you notice my border around the panel disappeared. Because before I had this little, you know, outline of the panel area. That's not there anymore. That border is drawn by the paint method normally. So let me change the location of this first of all, so I don't have to keep dragging it over. Alright, so if I were to come in here and I were to change the name of this paint method to paint, right? I've got a method with this name in there. It's not the paint method anymore. So the only paint method in my panel is the default paint method. And if I run that, you know, I've got the nice border that I specified when I said do a beveled border. But of course there's no circle being drawn because it's not using my paint method. So the problem here is when you override a method, you completely replace that method. So this is the one and only paint method in my panel. And I haven't written code in here to say, hey, check the border, and if it says it's a bevel, draw a line, and so on and so forth. So here's where we're going to use the keyword super. What we're going to do here in the beginning of paint is we're going to call the original paint method from the super class, which was JPanel. Stuff is a technical word. So do the original stuff from JPanel's original paint method. So if I run this, there's my panel, I've got my rectangle drawn, I've got my old border back. And this is persistent. If I occlude, you know, part of my window and then I make it visible, it reappears, it's getting drawn automatically. That's being managed by Swing. Right? I don't have any code in here which says, you know, if the window gets bigger, then go ahead and redraw, call paint again, and so on. Right? That's taken care of for us. But the flip side of having all that taken care of for us is this business where we need to sort of negotiate with Swing when we want painting to happen. Alright, we got 61 seconds. That's not a lot of time. Alright, so we'll see this a lot. We're going to create our own graphical class, right? It's going to extend an existing class just so that we can add some extra features to it or change some default behavior of it. So in this case we made a My Panel and did some extra stuff in there. So so what do we want to do next? We want to look at how we set things up in memory and call a method named repaint in order to cause paint to be called. We're not allowed to call paint directly ourselves for a variety of reasons, but basically to do with the fact that Swing is running in the background and there's a thread that's taking care of drawing our window for us, and if we start, you know, directly drawing at the same time, we'll end up with a muddled up display. Right, so you have a canvas and you have 10 people trying to make a painting. You only want one person to have a paintbrush in their hand, maybe. And then other people can say, you know, add some yellow over there, draw a line over there. But you get a very different experience if all 10 people have a paintbrush and paint. It's not a bad thing, actually, for an art project. But for Swing, it would be really bad. You end up with a lot of conflicts. Does it have a default frame rate? Probably. I don't know, though. I think that's more a factor of the display manager than Swing itself. But it's I believe it's synchronized to draw, you know, during the refresh, and you can get into various degrees of interaction with the actual display manager of your system. But yeah, you can do some animation like this too. It's totally doable. Alright, we are beyond time. Mess around with that. Think about PA4. Think about groups, right? Get together with people if you want to work with them. Do some strategizing. Think about sort of general layout. And if you want to start messing around with some of this stuff, we'll start digging a lot deeper into this on Monday. that's all I got. Have a good weekend. Watch out for falling hail. And I'll see you next time.